So let's determine whether or not a table of values could represent a function. As you look at this table, you're going to see that we've got some values highlighted. We've got a couple of 3's in the x column and their y counterparts. And I want you to realize that based on what we've already learned, if there is the same number in the x column and they give different answers in the y column, it's not a function. It's that simple. So when you see duplicates in the x column, check out the y. If those numbers are different, then it's not a function. So here's one for you to try. Now let's play around a little bit like a puzzle and see if we can figure out how to turn this table into, for sure, possibly representing a function. We're going to put the values of 1, 4, 6, 9, and 3 in there. Okay, they're already in there. Some of them, well, they all are. And then we're also going to put more numbers in there. So, in order to keep the x column always different, notice that 1, 9, and 3 are already used. So the only thing we can do is use 4 and 6 in that column, okay? So we're going to put 4 and 6 in there. And I think I'm going to do it like this so that they don't end up giving their same answer when you plug them in. I don't know. And we can't put, well, the rest of them don't matter as much, okay? We have 1, 3, and 9 left to use. So I'm just going to put a 3 there. Let's see, what else do we have left? 1 and 9. So I can't put 9 there. I want to put a 1 there and a 9 there. And now you can see this is possibly a function. We don't know for sure, but it's possibly a function. So now, what if we wanted to turn this into definitely? So using the same table and the same numbers, how could we play around with it and make it so it does not represent a function? What we would have to do then is to repeat something in the x column. That's all there is to it. So basically, there's lots of ways we could do this. I mean, we could repeat the 1 here. And then we could even repeat a 3 here. All right, whatever you do there, it's got to be something that was already here. Okay, so I've got 2 1s. Now what I got to do is pick a different number for the answer to the 1, because if I pick a 4, then the 1 is always giving us 4. So let's say I'm going to pick a 9 here. And then down here, 9 and 3, let's see, the 3's got to pick a different number than a 6. So I think I'll pick a 1 for the 3, okay? And then the 9 gets what's left. What was that? That was a 4. And we also have 2 different x's that come up with the same y. Not good. Not good at all for a function. So here's one for you to try. Okay, linear functions in equations, tables, and graphs. That's where we're headed now, so that you can recognize them in all those places. We've talked a little bit about it. Linear functions mean they're going to give us a line, okay? Let me slide myself down just a bit. There we go. I didn't want to cover up all those words. Okay, equations of linear graphs or linear functions. Take a look at the top there. Those are the all examples of linear functions. Notice that none of the variables have a power higher than 1. Okay? All of them have a power of 1. That is highly important, because if you look down here, you're going to see these are not linear functions. These are going to give us all kinds of curves, the curvy ones that you've been seeing. This one is the square root of x. Okay? That's a square root. Here we have a square. Here we have a cube. Very simple definition, okay? Look for the variables, look at their power. If it's got a power of bigger than 1, then it's not a linear function. It might be a function, but it's not a linear function. big difference. Now, I want you to think about that word linear. I know I've told you this before. The word linear has the word line in it. So when it says linear function, we're talking about functions that make lines when we graph them. So, which equation is not a linear function in this one? Okay, so we're going to distinguish linear functions, linear equations from tables. I want you to see that y equals 3x plus 2. As I plug in values for x, notice over here I have 0, 1, 2, 3. Notice, remember I always like to start with 0. It's one of my favorite things to start with when I'm doing these kinds of things. Plugging in 0 gives me 2 for y. Plugging in 1 gives me 5 for y. 2, 8, 3, 11. Get it? It's very simple. And if you notice, each of these gives me a different value for y, okay? Each of the x's. And if we keep plugging in a 3, we're going to keep getting an 11. There's nothing that can change. Now, how do you distinguish them in a table for sure, okay? Here's how we do it. We figure out the changing. How is it changing? Start at the bottom. We take the 3 and we subtract the 2, okay? And we get 1. 2 subtract the 1, we get another one. 1 subtract the 0, we get another one. On the other side, we do the same thing. Take the bottom number, 11 minus 8, we get, 11 minus 8, we get, 5. No, sorry, 11, that should say 8 right here. That should say 8. 11 minus 8 is going to give you 3. Because 11 minus 5 gives you 6. Oh, for goodness sake. So on another, let's see, was this the same one we just looked at? Zero, 1, 2, 3. Yes, it is. Okay. So using that same graph, I want to show you how we can determine if I don't give you the equation. So looking at the same graph, I want to show you if I don't give you the equation, if you're not given the equation, how do we decide if it's a linear equation without being able to figure it out? So we're going to take the change in these variables. Okay, the change in x. Start at the bottom. 3 minus 2 equals 1. 1. Going 2 to 1, again, from 1 to 0, the change is 1 again. So all of these are the same. The change from 11 to 8 is 3. From 8 to 5 is 3. And 5 to 2 is 3. We call that the change in y over the change in x. If we can do this subtraction, and every one of them end up the same. The change in y over the change in x is the same. Even if they're different, but they can be simplified to the same number, the same fraction, then we know we have a linear equation. So what happens if that doesn't work out? Let's take a look at this one. 10 minus 5 is 5. 5 minus 2 is 3. 2 minus 0 is 0, or is 2. Over here we get 2 2's. So the change in y is always 2, but notice the change in x is changing. So when we put them together like this, we don't get the same, we can't simplify them. They're all simplified as far as they go. We don't get the same change in y over the change in x. This is not linear. Now I want you to figure out which one of these is not linear. Graph points and decide if they represent a linear function. Now, graphing is the easiest thing of all. Okay, notice we're taking this equation here, very simple one, y equals 2x, and plugging in numbers for x. 0, 2, and 3 were plugged in. I probably, if I had written this little chart, I would have said 0, 1, 2, 3, or something like that. But what I want you to remember is, in order to graph a line, you must have at least 2 points. Must. However, get 3. Always get 3, because that third one will help you decide, was I right on both of those other 2, or did I mess up? We always want to double check ourselves. So when we plug in those x values that we have here, we get these y values, and these become our coordinate pairs. So we're going to plug this into our graph one at a time. First, we're going to do the 0, 0. Now we'll do the 2, 4. I hope you guys remember how to do this. Always go left or right, depending on if it's positive or negative, then go up or down. Okay, remember, step into the elevator first, and then you can go up and down. Okay, you got to step in the elevator before you can go up and down. Last one we're going to graph is the 3, 6. Now, when we bring our line into it, take a good look as it comes on up, it connects the dots. If it didn't connect the dots, it wouldn't be a linear function. Okay, it might be a function, but not a linear one. Okay, easy stuff, not hard at all. Let's take a look at another example. Here's an example already graphed for us. What do you think? Is this a linear function? Well, let's see. Can I connect the dots, all of them, with one line? If I bring in a line, look at that. I connect those two, but it's nowhere near the other two. Okay, what we have so far looks like a function, but it is not a linear function. Okay, which one of these is a linear function? And last but not least of all your questions, which table belongs to that linear function? Well, I hope you understood what went on today. Learning about functions, linear functions, identifying them, plugging in numbers. Please take some time to make sure you understood it. If you missed anything, go back and watch it again. I hope you all have a great day.